Dear folks, we are going to solve this problem. It is the transportation Hungarian minimization assignment problem. In this, you see we have the 4 operators and 4 machines. So it is a balanced problem. So in this, you see the time of completing the operation by operator 1 is 10 minutes. By operator 1 with machine B 12 minutes, with machine C 9 minutes, with machine D 11 minutes. So second operator will be taking 5 minutes. So you see this operator is taking the lesser minute than the operator 1 in the machine A. So we have to minimize the time through the Hungarian method. So let's solve it. So start with the first step, that is the raw minimization. In that you have to find the least value, that is 9. Then in the another row it is 5, another row it is 11, another row it is 8. So you see these are the least values. Now what we have to do, we have to subtract these values with the elements which are inside. So remember, the one value of every row would be 0. Like this value would be 0, this value would be 0, this value would be 0, and this value would also be 0. So let's make it again. 10 will not be 10 anymore. It will be 1. Since 9 has to be subtracted from the first element. 1, 3, 0, 3. It's 2. 5 minus 5, 0. 5, 2, 3. 1, 3, 2, 0. 0, 7, 3, 1. So you see now after the raw minimization we have this matrix. In that you see now we have to go for the second step, that is the column minimization. In that you see the least value is 0, the least value over here is 3, the least value in this is 0, the least value is. Now after this minimization, the column minimization, this column would be the same. 1, 0, 1, 0. Zero. 5 minus 3 is 2. 3 minus 3 is 0. 7 minus 3 is 4. 0 would be same. 2, 2, 3. 2, 3, 0, 1. So now you see after the row and column minimization we have this matrix. In this matrix you see we have multiple zeros. So now we have to start assigning. So first in that you see we have in the first row we have 2 zeros, so we cannot assign, since we can assign only a single 0. In the second row we have a single 0, and when assign you have to cut the whole column like this. The whole column is cut. Now in the third row we have 2 zeros, so we cannot assign. In the fourth we have no 0. In the first column we have 2 0, we cannot assign. In the second column we have 1 0, so yes, we can assign. And we have to cut this like, and in this column we have a single 0. We have to assign it, and we have to cut this. Okay, now you see we have assigned the three operators have been assigned, but still one is remaining. So let's find the remaining one. So remember what we have to do. We have to find the uncut in any of the uncut values, that is 4 3 1 2 2 3, the one which is the least. So 1 is the least, so 1 has to be subtracted from all the uncut values, and it has to be added from the values which are at the intersection, like 1, okay, like this one, so which are at the intersection. So it will be increased by 1. So increased value would be, I'm writing with the blue pen, that is 2. Okay, so that is 2. Okay, so 3, this is at the intersection, and this is at the intersection, so both are. So rest of the uncut values will be decreased by 1, like 2 would be 1, 2 would be 1, 3 would be 2, 4 would be 3, 3 would be 2, 0, and the rest will be same. Okay, the rest will be same. 2 0 0 2 0 0 2 0 0. Okay, now this is the matrix we have. Now we have to start assignment. First, in the first we see the 2 0 are there, so we cannot assign. In this second we can assign, so we will be assigning this, and when we will assign it, we have to cut this column. Okay, now let's go to the second. Second is already assigned, third 2 zeros, and in the, so we cannot assign. The fourth we have 1 0, so we can assign. So when we assign over here, so we have to cut this. So now we have the 2 columns, one is here, one is here, the other one is here. So what we have to do, first we will assign over here. First we will assign in this column. So when we will assign this 0 will be cut. Okay, now in this row, in this column, you see there is a 0, so we have to assign this. So you see 1 2 3 4 assignment is done. So we are done with the problem. Operator 1 assigned to the machine C. Operator 1 assigned to machine C. Operator 2 assigned to machine A. Operator 3 has been assigned to machine B. Operator 4 is assigned to machine D. Okay, in the first you see, at the first placement you see 0 is over here at this location, so 9 would be the time. When the operator 1 is assigned to machine C, 9 would be the time. Operator 2 is assigned to machine A from here, so the cost would be 5. Operator 3 was assigned to machine B, the cost would be 14. Operator 4 is assigned to machine D, the cost is 9. So in total, 9 plus 9, 18. 18 plus 5, 23. 23 plus 10, 33. 33 plus 4, 37. 37 is the total time the operator 1, 2, 3, 4 take to done the job. Thank you very much.